Yeah, I will. Today, I was going to talk about my experience with working in bamboo after the earthquake. In Nepal, we have, according to the last census, we have 74% of our construction in the whole country is built with natural material. And like if it's natural material, mostly 100% of the time, or close to 100%, the roof or any tensile member of the construction would be with bamboo, or timber, but mostly bamboo, because timber, people do use timber, but in the mountains the timber are not long enough that people use bamboo for construction. And and also people use reinforcement with bamboo. And so there's a big tradition of using bamboo in our country. So according to the data, like 2/3 of our buildings has one or other elements of bamboo. But the problem is these materials are considered in our context in Nepal as what we call kacha material or temporary materials, right? So, we have like tradition of treatment of bamboo, using water treatment, soaking, leaching, and smoking. And using this technology, people have made bamboo structures that have lasted more than 100 years. But unfortunately, it's considered a temporary structure. And also the thing is, but that doesn't mean that you are not allowed to build with it. You can build with it, but you don't get bank loans or other recognition from the government. So after the earthquake, before the earthquake, I had been advocating use of bamboo, especially for the roof. If people don't want to use everything bamboo, that's fine. But if they use bamboo for the roof truss, it would definitely be very helpful, because bamboo is ductile, it's elastic, and even if there's a shake, it will not. Even if it fails, it's not heavy that it's detrimental to health of the people who are living there. So with this concept, I'd designed a small public school, like a 3 classroom, using stone on the bottom and bamboo as a roof. And then we had a stone slate. It's very insulated. It was very well designed. But it took a long time because, to get the permission, to get the recognition, to get the funds. And it took, after 3 years, we built the structure. And interestingly, what happened, that building we built lied at the epicenter of the earthquake. And so interestingly, that was the only building that survived in the whole district, So all of a sudden, from a very fringe material, people started talking about bamboo. We got like good coverage in the media, from international media. There was a BBC did a nice report on us. There was on Al Jazeera, like focusing on how, there are alternative ways of building. Not all traditional constructions are weak. So that gave a really big momentum. So with that credibility, we went to the government and said, hey, you have to build 10,000 schools. After the earthquake, there were like a lot of damages. So, and I proposed, why don't you use bamboo as the material for, you can use other materials, but just use bamboo for the roof, because a lot of heat loss happens through the roof. And the most expensive part is the roof. So why don't you use bamboo? And it's available everywhere. There are a lot of reluctance, but some districts did allow us to prove, again. So after the earthquake, we built about 25 schools. By the way, Kamesh, I've already sent the presentation. So I sent, so we built about 25 schools using bamboo, and we made this whole design as open source. So meaning anyone who is interested can download the design and use it, right? So we have hundreds of downloads. We just prior to, apart from traditional schools, there were a lot of transitional homes that needed to be built. And there were about 10,000 transitional shelters that were built using the open source technology that we gave out. So what we did was made very simple, in terms of standardization, you cannot, bamboo, as we know, is a very homogeneous, heterogeneous material. It's not perfectly round. It doesn't have, you cannot be standardized. But something that can be standardized is the joint. So we did a lot of testing on the joint. We had a small metal joint. And so it was slightly bigger than, let's say the diameter of bamboo is 80 centimeters, most of them. So we did about 90 centimeters.
To you. You can just open it. Yeah.
So, so about 90 centimeter. So this way the joint became standard, while the rest of the components were like in its raw form. So using this, it was a very successful movement, I should say. And so many people build a transitional homes, schools, about 25 schools were built using this technology. And also we gave for regular homes also. But from our experience, what we found out is people are very reluctant to make their own homes with bamboo. And one of the reasons is nothing to do with the material. It's because of craftsmanship. Bamboo is, you need a very skilled person. Like if you work with timber, you're working with a fixed geometry. There's 2x4s or 4x4. So there's a fixed geometry that you're working with. But if you're working with bamboo, it's round. So craftsmanship was a bit difficult. But as in a whole, we try to make that little bit more accessible by making that joint part with metal. And using that, we were really able to scale. Oh, great. Yeah, so as you can see, these are like the documentation of all the traditional bamboo homes in Nepal. So even if it's earthen homes, usually the truss, the beams are always made with bamboo, right? And also the other thing they do is when they do wattle and daub, they flatten bamboo and then do mud plaster over it. And mud plaster, what it does, it sucks the moisture, and so when there's no moisture, there's no insects. So that's the traditional way of treatment. So you even like the house, you see all the truss members, the beams, are usually made with bamboo. And the outside version, they use timber. Next. So yeah. So just stop there, please. Next. Yeah, so this is a very typical timber and bamboo house. Like the outside, the columns are timber, but the inside, everything is bamboo. It's wattle and daub. They do multiple stories also, up to 2 stories. And also one of the tradition, like please leave it here. This is a bridge that we had a big tradition of building in Nepal. This is about 30-meter bridge, and the photo is from 1895. It's a bridge that's connected using rattan, and it has a very similar concept of a modern suspension bridge. But unfortunately, we have lost this skill, because this was never encouraged. Here's another bridge from Nepal and Sikkim border. So this is more using rattan and bamboo as the structural element. And unfortunately, we have forgotten that technique, and this is what this is the typical bridge now people are using in very remote areas. Next. So this is the census data I wanted to show that around 74% of our constructions are still using traditional material. And as I said, and in some areas in Midwestern Nepal, the level of cement penetration is only 0.2%, not even 2%, 0.02%. Yeah, can we go next, down? Down, yeah. So we can go down and like, actually the word Kathmandu, you know, like I come from Kathmandu. Kathmandu means, Kath means wood, and Mandu means the place. And so traditionally, everything was made with timber. The whole city was built with timber. But unfortunately, we have lost that tradition. Now it's become cement Mandu, you know, cement structure. Go next. And it's unfortunate because Kathmandu has the world's largest amount of a world UNESCO heritage site, and most of them have timber and bamboo in their joining. And so there's a false narrative that's shown by the government that cement will be very strong while bamboo will collapse. But I did a very intense research in the epicenter, and we found out that 90% of the concrete buildings collapsed, while properly designed timber, bamboo, stone structures survived. Next. Next, please. Yeah. Next. I will not. Next. Next. Yeah, I'll not talk much about bamboo because I'm talking to the expert, but I want to show a few technologies and the innovations that we've used. One of the major innovation was the boucherie treatment. You know, we hacked a very simple system using a cylinder and a bicycle pump that we would take to the mountains. You know, we don't have a huge plantation of bamboo, and whatever bamboo there is, it's out scattered in the world. So using this boucherie technique, you can go, the person would charge very nominal amount and then joint and then treat it. And the second one was joint. This is the one I was talking about. The next one, please. Next one, yeah, please put it here. So here, the structural joint, yeah. So we did a very simple bracket, a steel joint. So this way, as I said, you don't have to standardize the bamboo, but at least you can standardize this joint. You know, most of the failures, as we know, happens in the joint. So once we have a very strong joint that can accommodate different diameters and sizes of bamboo, it made the construction much easier. So in the beginning, our primary focus was to convince people to use in the roofs. Here's one of the public halls that we did. You know, we said, okay, use whatever wall system you want, but make the bamboo roof. And so this is the school that I was talking about. So we use the traditional stone for the walls, and for the roof, we use bamboo. Can you go next? Yeah, so please stop here. So this is so we did a very properly designed truss using the metal system, you know, had a lot of cross bracing and a small opening for ventilation. And we did a nice plastering with earth. And this was the building that survived the earthquake. You know, it was at the epicenter of the earthquake. It was not, you know, it was 7.8 Richter scale, and this was at the epicenter. And so as I said earlier, this was the building that gave us credibility, that helped in jumpstart our construction project. After that, we proposed to the government, to use in their traditional school building bamboo as a construction material, at least for the roof. So we can we go next? So here, please stop here. Yeah. So here's the roof you see is bamboo. It's insulated with bamboo mats, and then we have a ventilation, a thick wall for thermal comfort, and we did mud plaster over it. There are a lot of niches. So like with the same budget that they were building for the traditional schools, we proposed with bamboo. Next. And so this is one of the schools. As you can see, the roof part is bamboo. It's very well insulated. You go next, please. Yeah, no, please stop here. No, yeah. So yeah, the roof is bamboo. As you see, the metal joint is the joints are metal. They're like very highly insulated. Even the furniture are bamboo. We even put a whiteboard in the furniture. So bamboo is, the furniture being lightweight. People can move around. That space becomes flexible. So this was an open source document that we put on our website, and people could download it. And using this, as I said, more than 25 schools were built. Even now it's getting built. And one of the most interesting part of this construction is the 89% of all the construction cost stays in the community, right? So it's not going outside. Only 11% goes in building, buying other materials. So after the earthquake, and it gave us a lot of momentum. So we built libraries, like public spaces, because that's where we found the need to be. In private homes, people are a bit reluctant. They'll be like, "What will my neighbors say?" But in public spaces, there's more acceptance. So we built this huge public library right in the center of the city in Kathmandu. So we use a lot of traditional elements. We use mud on the outside. On the outside, we try not to expose bamboo. Even though we treat it with pressure treatment, we understand it has certain limitation, because we use borax, which is a water, can be leached water. So we use it in the interior, right? So we did this public library, we built more credibility with that. And after that, we started getting more projects. So so here's some of the typical truss element. So we built another school. It's an orphanage. We use everything like you see behind. There's a bamboo forest. We just went there, got the bamboo, and built it. Next. Yeah, so you can see like a lot of elements are bamboo elements. Huge span structures. Like that's the beauty of bamboo. Its strength and its flexibility and its localness, right? So here you see all this, the walls are built with bamboo. The reinforcement is bamboo. The inside truss is bamboo. Yeah, if you can stop here a bit. This is a typical truss. We designed it such that it works as a truss as well as a jungle gym. So the kids can come and like climb on it. It has a pretty big span of about 9 meters. Yeah, so a lot of elements with this, you can see. So as you can see, we're not very reluctant to use bamboo with other materials, in order to get the strength that we need. So here we have used I-beams because the span was pretty big, but then we use bamboo for the joist, which, So we're using materials for its proper, like using it judicially where it has the best properties. And next, yeah. So as what I'm really happy to say that in Nepal, I've been working for about 12 years now, and the first 3-4 years it was very difficult because of the acceptance, but now slowly people are accepting. They're building their homes, they're building their we are building now a monastery using this material, which shows that and we are building public places, hotels, and private residences. So it's showing that there's acceptance. And just to stop this slide, finish the slide. What can you? Yeah, stop here, please. So we have also created a backward linkages. So we have, as I said, the bamboo in Nepal is not. We have a lot of bamboo, but it's not done commercial plantation. So we did a project where we took degraded land, like this land. There was a flood, and it was degraded like this. So and then we started planting bamboo. Can we go next? So one on the left is after the flood, and one on the right is after the bamboo plantation. And we've helped in training that river. And in 8 years, it's become very vibrant, well-trained river. Like you see, in 2001, this is the river. Next. In 2005, it started moving its course. Next. And 2010, there was a big devastation. All these white spots are, the area where the water went. Next. And 2014, we started by planting bamboo along the river. And 2018, it's become like there's now vibrant ecosystem. Yeah. Next. Yeah, so thank you so much. This is what we wanted to show, like we even making the bamboo bicycle. So in the streets of Kathmandu, if you can sometimes see our bamboo bicycle. So we try to create a whole ecosystem by bringing in communities and creating a small industry that's good for the people and for the planet. Thank you.